Hey everyone, and welcome back to Talk Tensors. Yeah, I know, today we're going to be shifting gears a little bit.
Oh,
Yeah, we've been talking about all those large language models and things, but today we're going a bit more mobile.
interesting.
Yeah, cooperative maneuver planning at intersections.
Ah, okay.
We're diving deep into this paper called Real-World Evaluation of Two Cooperative Intersection Management Approaches.
Okay.
And, it sounds a little bit dry,
Yeah.
but trust me, it is way more exciting than it sounds.
I can see why this one caught your eye. I mean, this paper, it really tackles a problem we all deal with,
Yeah.
traffic congestion.
Yeah.
Especially at intersections. But it's not just about the problem, it's about the approach. Like, it's not just about, making self-driving cars better by themselves.
Right.
It's about, making a whole system where the cars talk to each other, they coordinate, almost like a
Like a choreographed dance or something.
Exactly. And what's even more impressive is that, this isn't just simulations. They actually tested this stuff, with real cars in Germany. They even did it in mixed traffic with human drivers.
Oh, wow. Hold on. So they actually let these AI systems loose on the roads
Yeah.
with real people?
Yeah,
That's a pretty big step.
it is. And it really shows how much progress this field is making,
Yeah.
But, before we get into all the details of how this all works,
Yeah.
let's take a step back. Why are intersections such a big bottleneck?
I mean, we've all been there, right?
Right.
Just sitting at a red light.
Yep.
When there's absolutely no one coming the other way.
It's so frustrating.
Right?
Yeah,
Yeah.
and it's because even with all the fancy sensors and things,
Well.
traffic lights are still pretty dumb. They
Yeah.
can't adapt to the flow of traffic in real time.
Okay.
So that's where this cooperative maneuver planning comes in.
Okay.
The vehicles can actually communicate
Okay.
not only with each other, but with the infrastructure
Right.
to decide how to move through the intersection in a smart way.
So instead of just blindly obeying the traffic light, my car could be
Yeah,
talking to the car next to me.
exactly.
Okay, you go first. I'll go next.
That's a great way to put it. It's about moving away from those fixed rules.
Yeah.
Going towards this more dynamic system, a smarter system.
Okay, that makes sense.
Yeah.
So this paper focuses on two ways
Yes,
to do this cooperative maneuver planning right.
that's right. The first is called optimization-based planning,
Okay.
and it's all about predicting and figuring out the most efficient way for all these cars to get through the intersection.
So it's kind of like a
Yeah.
super-powered GPS
Yeah.
that not only knows the best route,
Yeah.
but also how to work with all the other cars to make
Yeah.
sure nobody crashes into each other.
You got it. It uses these really sophisticated algorithms to figure out what other vehicles are going to do, and then it calculates the best path for each car, all to avoid collisions and keep the traffic moving smoothly.
Wow, that sounds really, really complex.
It is, and especially when you consider that,
Yeah.
human drivers, we don't always
Follow the rules.
follow the rules, right?
Right.
And we don't always behave in a predictable way.
Yeah.
And that's where the second approach comes in.
Good.
This is called reinforcement learning planning.
Reinforcement learning. That sounds kind of familiar.
It might. It's similar to how we train AI to play games.
Oh, right.
This approach uses a special kind of neural network. It's been trained in a simulation
Okay.
to make smart decisions at these intersections.
So it's like the AI has spent hours and hours
Yeah,
playing a hyper-realistic driving simulator
that's a great way to think about it.
until it becomes like the master
Yes.
of navigating intersections.
You got it. And what's really interesting about this approach is that it can adapt to unpredictable situations
Right.
and learn new strategies on the fly, which is really important when you've got humies in the mix.
Right. So we've got these two approaches.
Right.
One that's all about predicting and calculating.
Right.
The other one is more about learning and adapting.
Yeah,
And they're both designed to work with human drivers and self-driving cars.
exactly. And here's the really exciting part.
Okay.
They didn't just keep this in the lab.
Yeah.
They actually took these systems out into the real world.
Oh, wow. Seriously. They actually let them drive around with real people.
Yeah.
Tell me everything.
Okay, so they took these systems out of the lab and into the real world with real cars and real people.
Yeah. And I want to hear how those real world tests went.
Yeah.
Did the AI actually live up to the hype?
They did. In some cases, the results were really impressive.
Oh.
But before we get to that,
Yeah.
let's dig a little deeper into these two approaches.
Okay. Let's start with the optimization-based planning.
Okay.
You said it was all about prediction. How does that actually work in practice?
Okay. So imagine the system is kind of like a chess grandmaster.
Okay.
thinking many moves ahead.
Okay.
It generates all these predictions for how the traffic situation could unfold. Taking into account the speed and the trajectory of each car,
Right.
their planned route, and even, the chance of a sudden maneuver.
So it's not just predicting one outcome.
Right.
It's thinking about, like, a whole bunch of possibilities.
Exactly, like having a magic crystal ball showing you all these different potential futures.
Okay.
Then the system looks at each scenario and decides which one is the safest and most efficient. It's picking the one that gets everyone through the intersection the smoothest and with the least risk.
That sounds incredibly complex.
It is.
Does it also consider that humans don't always follow the rules?
Absolutely. That's where the driver model comes in. It's like a mathematical
yeah.
version of how humans tend to behave in different situations.
Oh, okay.
Like, their reaction times, how long it takes them to break even, their tendency to speed up when the light turns yellow.
So the system, like, knows how the average driver thinks and uses that to anticipate their moves.
You could say that. It's all about making sure the system is ready for anything in the real world.
Okay, that makes sense. What about the reinforcement learning approach? How's it different?
Well, instead of using pre-programmed rules and complex calculations,
Okay.
the reinforcement learning system, it learns from experience.
Okay.
It's kind of like training a dog with treats.
Okay.
You reward good behavior,
So, like, back to that video game analogy.
Right.
The AI is learning by playing tons of rounds of navigating intersections.
Exactly. It uses this neural network called a graph neural network,
Okay.
or GNN for short,
Fuck.
and it's trained in a simulated environment. So it gets rewards when it does good stuff,
Right.
like getting through the intersection quickly and safely.
Right.
But it gets penalties when it does bad stuff, like
Yeah.
almost causing an accident.
Okay, so it learns through trial and error,
Yeah.
and over time gets better at navigating
Exactly.
urban sections.
Precisely. And unlike the optimization-based approach, this one doesn't need someone to program in every possible scenario.
Right.
It can adapt and learn new things on the fly, which is super important with all the craziness of real traffic.
That's pretty cool. But how does this GNN actually see what's happening? Does it have, like, virtual eyes?
Well, not exactly eyes, but it has something called input features.
Okay.
It's basically pieces of information about the surrounding environment.
Oh,
Like, the position and speed and direction of the other cars, the layout of the intersection, that sort of thing.
so it's like giving the GNN a real-time map of the intersection.
Yeah,
With little icons or something for each car.
that's a good way to think about it. And remember, this is designed to work with both human drivers and automated vehicles.
Right, which brings us back to those real-world tests in Germany.
Yeah.
Did they film any of this?
They did, and we'll put a link to the footage in the show notes.
Awesome.
But basically, they set up this special site in Oberlahr, Germany,
Okay.
that was designed just for testing connected and automated driving. They had all these sensors and communication networks, and they even had an edge server to handle all the data moving between the vehicles and the infrastructure.
So it's like air traffic control, but for cars.
Exactly. They tricked out these 3 prototype self-driving vehicles with all the tech they needed
Okay.
to talk to each other and to the infrastructure,
Okay.
and then they let them loose in different traffic situations, some with human drivers.
Okay, so drum roll, please.
Uh-huh.
How'd they do?
Both methods, the optimization-based and the reinforcement learning.
Okay.
Both of them significantly cut down on travel times compared to regular driving,
Wow.
even with human drivers in the mix.
So it actually works.
It does. Of course, there are still some challenges, especially when it comes to, really integrating human drivers into these systems.
Right.
But these tests show how powerful this tech really is.
Okay, so less time stuck in traffic.
Right.
That's definitely a good thing.
It is.
But didn't you say that they were also focusing on safety?
Yes, absolutely. Safety is the top priority.
Yeah.
Especially with systems that make decisions on their own.
So how do they measure the safety?
They used a few key indicators. One was time to collision, which measures how close a vehicle gets to something else.
Okay.
Could be another car, a person, even like a stationary object.
Right, so the closer you get without hitting something, the riskier it is.
Exactly. It's like when someone cuts you off and you're just inches away from an accident.
Yeah, exactly.
They also tracked how smoothly a car slows down. We call that deceleration rates.
Cool.
Sudden or jerky braking can be dangerous, so they wanted to make sure the systems weren't causing any aggressive driving.
So it's like the difference between a smooth driver who knows what they're doing
Right.
and someone who slams on the brakes at the last second
Exactly.
and sends everyone in the car flying forward.
Uh-huh. You got it. And then they also looked at what's called post-encroachment times,
Okay.
which is a fancy way of saying how much time passes between one car leaving a potential danger zone and another car entering it.
Okay. So it's about making sure cars don't get too close to each other,
Yeah,
especially at intersections where there's lots of merging and turning.
precisely. It's like this perfectly timed dance where each car has its own space and timing to avoid collisions.
I like that analogy.
Thanks.
So what did they find?
They found that both cooperative maneuver planning systems actually did pretty well in terms of safety. They didn't see any big increase in risky situations.
Okay, that's good to know.
Oh,
So less traffic and safer roads.
Yeah.
Sign me up.
uh-huh. But before we get too carried away with the future,
Yeah.
I know there are always challenges and potential downsides to new tech.
Right.
What are some things we should be thinking about as this tech moves forward?
Well, one of the things that comes to mind is, scaling this up.
Yeah,
These tests were done in a pretty controlled environment, right?
right.
With only a few cars.
Yeah.
But imagine trying to do this in a whole city
Yeah.
with millions of cars,
Yeah.
pedestrians, buses, bikes.
It's a whole other ballgame. The amount of computing power you'd need is huge.
Right.
Not to mention all the data that would have to be flying around between the vehicles.
And the infrastructure?
Yeah, you'd need super fast and reliable networks.
Right. It's like building a whole new internet just for cars.
It is.
And what happens if there's a glitch?
Right. And then there's the security issue.
Right. Yeah, someone could hack into the system.
It's a real risk. And if someone took control of the system and started manipulating traffic,
That's like straight out of an action movie.
it is. And the potential for chaos is very real. That's why cybersecurity is going to be so important.
Yeah, for sure.
And then there's the whole logistics of actually implementing this, upgrading infrastructure,
Right.
putting new tech in all the cars,
Right.
maybe even changing the laws.
It's a massive project.
It is. And even if we figure all that out,
Yeah.
we need to think about how this will change society. How will this change how we live and interact with our cities?
That's a really good point. I mean, on the one hand,
Yeah.
less congestion could mean less noise pollution,
Right.
cleaner air.
Exactly. And it could even mean more green space
Right.
as roads become more efficient.
So it's not just about saving time on your commute.
Right.
It could actually make cities better for everyone.
It could, but there could also be some downsides.
Yeah, that's true.
Like, what if self-driving cars get so good
Yeah.
that people start living further and further away from the city?
Right.
It could lead to more sprawl.
I make inequality worse.
Exactly. So we need to think about the big picture. How will this affect urban planning,
Right.
public transportation, social equity, all of that?
Yeah, for sure. And it could also change what it means to drive.
That's right.
Will it make driving boring?
Mm.
Or will cars even be necessary anymore?
I mean, some people love driving.
Yeah.
The feeling of control, the challenge of navigating traffic.
Right.
But for others, driving is just a chore.
Yeah.
They just want to get from point A to point B. Cooperative maneuver planning could give people back that time and energy.
So it's not about getting rid of driving.
Right.
It's about giving people choices
Exactly.
and making transportation better for everyone.
And speaking of choices,
Oh, here we go.
it's time for novel notions.
I'm ready.
This paper focused on cars.
Right.
But what if we expanded this to other ways of getting around?
Okay.
Imagine a system that coordinates cars, buses, bikes, even pedestrians,
Wow.
all working together in one giant transportation network.
That's a really cool idea.
It is.
But it sounds super complicated. I mean,
Yeah.
how would you even coordinate all those different things moving around?
It would be tough. We'd need new sensors and algorithms
Right.
that can understand how pedestrians and cyclists move.
And people aren't always predictable.
That's for sure.
People jaywalk,
Right.
ride bikes on the sidewalk, all sorts of things.
We'd need a system that can handle all that
Yeah.
unpredictability.
So it sounds like there's a lot of work to do, but the payoff could be huge.
It could.
I mean, imagine a city where everything flows smoothly.
Yeah.
No more traffic jams,
Right.
less pollution.
It's a pretty amazing vision.
It really is.
And who knows what other novel notions we'll come up with.
Right. As this technology keeps developing.
Yeah, the possibilities are endless.
They are.
Well, I think that's a good place to wrap up our deep dive on cooperative maneuver planning.
I agree.
It's been a fascinating look at the tech and the bigger picture, too.
It has. And as always, we encourage our listeners to keep those brains working and come up with your own novel notions.
This is Talk Tensors signing off.